Here we have the Fall 2011 EF-151 final exam. The first four problems are multiple choice, 1 points, so we'll work through those together here. Number one asks us to determine the Y component of the 200-pound force as shown in the picture. So the key point here is that we're given a Y and X coordinate system, and we are given this force angle relative to the X. So let's draw the components of that force. We would have a Y component going downward and an X component going sort of up and to the right. Okay, so this 40-degree angle is this 40-degree angle, and that's the opposite side, so that's going to be 210 sine of 40. Okay, it's going to be minus because it's going downward. Our Y direction was upward, so minus 210 sine 40 is choice D here. Number two, we're given the normal force. We're asked about the normal force on a 74-kilogram person when they're at the top of a Ferris wheel spinning at 4 RPMs. So we did several examples like this when we talked about rotation and centripetal or normal acceleration. We usually drew a free body diagram and a kinetic diagram. You don't have to do this for the exam, but this will help explain here. Okay, and we're at the top, so that the mass times acceleration, normal acceleration vector is pointing towards the center, so it's pointing down. The weight is pointing down, and the normal force is pointing up. So our equation in the upward direction is positive. Our equation in the vertical direction would be N minus W is equal to minus M-A-N. Alright. Solving for normal force is equal to weight minus M-A sub N. Alright, so this will let us see that the normal force is less than the weight because we are subtracting off the MA sub N term, so it's less than the weight. Another way of thinking about this, if you can imagine the Ferris wheel going really fast, you would tend to be thrown off the Ferris wheel here, and so that means your normal force on your seat is getting less and less as the Ferris wheel gets faster. Alright, number three, objects A and B collide and stick together. What is, there's a typo there, the x velocity of the objects after the collision? Or maybe it should be r. What are the x velocities? I guess it is because the objects collide together and stick. So there's an important point here. That's a perfectly inelastic collision. The masses are given of each object, and speeds of each object are given in these terms, and so we're not asking you to calculate numbers here, just determine if it's positive, 0, or negative. So let's think about the x direction and just sketch out these two objects. We have object A going to the right at 20. Okay, and its mass is 10 kilograms. And we have object B. So let's look at logic B. It's in the x direction, is going to the right. Remember, momentum is a vector, so we can split the directions. Okay, and it's going to the right at 20, and its mass was 10. So a lot of words and vectors here, but what this reduces down to is two objects of equal mass colliding. Okay, if they have equal and opposite velocities in the x direction, their final velocity after the collision would be 0 because their momentum, if I were to write it out, again, you don't have to do this for the equation or for the test, but it would be 10 times 20 plus 10 times minus 20 is equal to 10 plus 10, the combined mass, times the final velocity. Alright, so the left hand side of the equation here is 0, so V prime would be 0. And lastly, then we're asked about the net torque about the origin of a system shown, counterclockwise being positive. Usually when we had angle forces and horizontal and vertical dimensions, we broke the force into components, so I will do that here. This will have a downward component, and I'll draw the horizontal component here because it's important to apply them at the same point. Okay, so this horizontal component is adjacent to our 30-degree angle, so it's going to be 40 cosine of 30, and that makes this vertical component 40 sine of 30. This horizontal component, line of action, is going right through the origin. Okay, so it has no effect on the torque. This vertical component has a horizontal distance of 2. Okay, and it's tending a clockwise rotation, so it'll be negative. So our answer is one of these two, the negative. The distance is 2 in both cases, and the magnitude is 40 sine of 30. So choice D is the correct one here.